Hi everyone, this is Steven, host of Computer Art Explorers. Welcome to our Introduction to Computer Programming series. In this episode, we are going to explore how to use string variables. Before we get started, we do want to mention that for the best viewing experience, please watch this video on a monitor having a resolution of 1920 by 1080 or higher. And you want to watch this video in full screen mode. Also, make sure that your YouTube settings are for high definition 1080. And to get started, I'm going to double click right here on this Ascii application developer. Come up to the file, click on new, and I'm going to paste in some text. This documentation meta command, what this means is that everything below this line is going to be documentation. This is a super meta command that simply, when I click on it, it generates this button here, and it's going to take us to section 33, page 6 of the manual. So I'm going to go ahead and click on that now, and you notice down here, again, we're at section 33, page 6. So if you want to go ahead and follow along on your computer, you can just go ahead and just click on the Ascii big button. You can go over here, click on section 33. You can come down below, so you can click on page 6. And let's go ahead and start off by reading this. String variables are used to hold any number of bytes of data up to the len max limit. The data itself may represent anything. For example, ASCII text, graphic pixel data, etc. In other words, you can put anything into a string that you want. Therefore, the ability to easily access and manipulate string data is one of Ascii's most powerful features. Now let's go ahead and take a look at that len max. Notice what it tells you. It needs one parameter, and it happens to be a dummy parameter. A dummy parameter means that it doesn't matter what value you put in there. You can put just 0, okay? It's not doing anything with it. It's whatever value you have in here just doesn't matter. So you can also, to indicate that in your code, you can actually use the keyword constant dummy. Notice DUMMY turned purple. Turned purple because the Ascii application developer is recognizing that as a valid keyword, and that's just a nice way to put in your code so you can know in your code that that value doesn't have any meaning. So let's print out the value of len max. The output is the maximum individual string length in bytes. So I'm going to go ahead and compile and run this. And this happens to be, under the current configuration, 500,000. So it's saying that an individual string can be up to 500,000 characters long. In this video, we're going to kind of go over all of these different string functions. So this is going to be a long video, and we're going to talk about how to use everything and give examples of all of these throughout this video. But before we do that, because this is extreme beginner level, I'm going to assume that there's people that are watching this video that have never programmed before, really don't know what an Ascii chart is, maybe you've never seen an Ascii chart, don't understand how it works. So I'm going to go over all of that, and I'm going to start now. See the lookup right here? I'm going to hit quick ref. I'm going to go to Ascii chart. And what I'm going to show you is that you have 256 characters that are defined in what's called a standard Ascii chart. And you'll notice that you have all the letters of the alphabet in uppercase. You also have all the letters of the alphabet in lowercase. So each one of these letters has been given a number. And so let's to make sense of this Ascii chart, let me explain how the computer does this. Computers can only really store things at the 1 and 0 level. Think of a light switch on a wall. Okay, the light switch is either on or it's off. So for example, I'm going to copy a couple things up here so we can look at them. And if you think about it, if you have a switch on the wall, the switch is either off, which can be represented by the 0, or it's on, so you have a 1. And so therefore, you can represent two values, a 0 or a 1. If you have two switches on the wall, say you have two switches next to each other, right? Well, if both switches are off, that would represent a 0 value. If the right switch was on, but the left switch was off, you would have a value of 1. If it was just the opposite, if the left switch was on and the right switch was off, you could say that that represents a value of 2. And if they're both on, that represents a value of 3. Number between 0 and 3, or 4 possibilities. Now, if we expand this all the way out and you look at 4, if you have 4 light switches on the wall, the 4 light switches can represent a value from 0 to 15. And there's all the different patterns. It's every pattern that's possible. Okay? Now, in decimal, what's called the decimal numbering system, you have from 0 to 9, and then you have 10. So actually, if we do this, just to push it over, 0 to 9, then it goes back to 0, but we carry the 1 over to the next position, right? In hexadecimal, we have 16 characters. So in this case, we use A, B, C, D, E, and F to represent. A represents decimal value of 10, B represents decimal value of 11, and so forth. All right. So this combination right here, and this is called a nibble, by the way. 4 bits is a nibble. So this nibble, each nibble can be represented by a hexadecimal single-digit value from 0 to F. All right. Now, a byte of data is 2 nibbles in a row. Okay, and you can kind of see the pattern going all the way down to where you get all the way down here and it's FF. The reason it's FF is because this nibble is an F and this nibble is an F. Now, imagine if you had this combination where you had that combined with this, right? This represents a 2, right? Go up here and look at it again. 0, 0, 1, 0 is a value of 2, and all ones is a value of F, or 15. So in hexadecimal, this would equal F2. So this combination of binary digits, where you have 8 digits, and this, by the way, when you have 8 digits of binary data, that is also called a byte. All right, so a byte can hold a total of 256. And the reason is because it's 16 times 16. From 0 to 15 is 16 different numbers. And if you have 16 different numbers times 16 different numbers, you actually have a total of 256 different numbers. So 8 on-off switches. Think of 8 light switches on a wall, right? Or in this case, it's in memory. The computer memory is like little light switches at a molecular level, and they're holding a value of either a 0 or a 1. So when you have 8 of them, that can be represented by 2 hexadecimal digits. So let's go over and take a look at, for example, the letter A. The letter A is a 4 and a 1. So see here where it's the like 0040 means everything on this row starts with a 40. And then you add either a 0, a 1. You see how this is working? All the way to F. So in this case, 4, 1, hexadecimal 4, 1, is we're going to use that value to represent the uppercase A. So in memory, you have, if we go over to the 4, I could grab the 4, I could come over and grab the 1. Okay, and that is going to equal, what we're going to do is I'm going to start showing you this binary number right here is going to equal 41 hexadecimal, all right? Or, see how it's 41 right here. Now, here's what I'm about to show you in the CyBOS language, which you can do. So here we're printing hello world. Hello world is a string constant because we have it in quotes, and anything that's in quotes is going, and we have a print statement and something in quotes, it's just going to print that out directly. But let's say we want to assign that to a string. So a string is a string variable that's going to hold this value. And then if we print a string, but what I'm going to do something is I'm going to say print a string equals, and I'm going to put a string, whoops. I'm going to put a string like this, and I'm going to go like this, so that we're going to print this here, so it's a string equals, we've got, basically it's a greater than sign, but we're using it as like an arrow, and we're going to put in whatever a string, the value of a string is, whatever characters is being held by the variable called a string, and then we're going to print this. So let's just go ahead and run this and take a look at it. So here again, the value of a string, where the text that's being held by a string, is this right here. Now, if we said a string equals, and we say 41, this is a curly bracket, 41, another curly bracket. And I'll go ahead and take this out so it doesn't confuse the issue. So I'm going to go ahead and run this, and you guys can see what it prints. So here it prints, it's showing you that a string equals just the uppercase A. Now, if I wanted to say space 42, space 43, and notice how this is all in red. In red, it's indicating to you that that is string data, okay? So in the CyBOS language, you can have in curly brackets 2 hexadecimal numbers, a space, 2 hexadecimal numbers, space, 2 hexadecimal numbers, and the language, the compiler will actually convert that into the hexadecimal value. And of course that should be, if you look at your chart, okay, there's 41, 42, and 43, A, B, C, all uppercase. So I'm going to go ahead and compile it and run it just so you can see. And so there you go. All right, now, if we go, there's another command called binary. I'll show you something. Print binary string sub, I'm going to put 0041 and do this to make it easier to see. So I put curly brackets, and then I put in 4 digits of hexadecimal data in curly bracket. And notice it turned it purple. That's because when you have 4 digits of hexadecimal digits enclosed in curly brackets, that is telling the compiler that you are declaring the numeric value, not a string value. Okay, this is a string value, and the application developer is turning the text red as a visual indicator to you that that is being treated as string data. It's turning it purple as an indicator to you that it is numeric data, okay, and numeric integer data to be specific. So I'm going to go ahead, and then this command is going to print the binary string. It's going to convert this into a string of binary digits, and I will show you something. Let's go ahead and run this. And so you can see here that you have the 4 as far as this nibble right here, and then the 1. Now the integer is, this is actually a 32-bit integer. So if you notice, there's 4 bits here, 4 here, so that's a total of 8. This grouping is 16, 24, and 32. So this is what's called a 32-bit integer, and if you ever want to take a look at all the individual binary values of it, you can do it that easily. You can also say hexadecimal. You see the hex string of 41. And notice what you have here. Okay, so you have, again, each one of these digits. So there's 8 digits here, and there's 8 nibbles. And again, hexadecimal, the 1 corresponds to the binary, these 4 binary digits, and there's your hexadecimal 1. These 4 binary digits, hexadecimal 4. And then all the rest of them are zeros. Okay, so this is very, very useful, and you really need to understand this, because there's times that you need to take a look at your string data, and I want you to understand the fact that a string is just a bunch of bytes of data, all right, and of any given length. For example, if we want to know how long a string is, you can actually know what the number is. I'll go ahead and compile and run this. So here it's printing out the value of a string, or the text that's being held by a string, and then we're printing the length of a string and showing you that it's 3 bytes long, and there's your 3 bytes. Okay, now I'm going to show you a real-world example of why you might want to use this. Okay, let's say I'm going to have a variable, and I just want to put the fact that I am the copyright holder of this, right? So maybe I have a variable called copyright by string, and equals and there's my name. And maybe we want to turn around and say the length of this string equals the length of the string. And then let's go ahead and print the string itself. All right. But what I want to do is I want to put that copyright symbol in there. Okay, let's go back to the lookup. And I want the copyright symbol. So the copyright symbol is, see where it says A0? So this whole line is the A0 line. And then here's the copyright, and I go up to 9. So that's telling me that A9 hexadecimal will give me the copyright symbol. So there's A9. And notice it turned it red. That means that is going to be string data. Let's go ahead and run this and take a look at it. All right, so there you go. And it's showing you that the length of this string is 29 characters, and the actual data itself, you can see the little copyright symbol followed by the word copyright 2017 and my name. Okay, I added some code here. Let's go over what I've added. First thing I've added is this meta command to log the SCT, which is the string constants table report. I'm printing hello world, printing Joe Q public. Then what I've done here is I've added data, which is going to add data into the string constants table. Right? You could also have data, you know, put in quotes. Okay, put in quotes, something like that, just to show you. And then I'm going to go ahead and run this. All right. Now, it printed hello world, it printed Joe Q public, and then it printed this here, which is the copyright ABC. So let's take a quick look. This made sense. We have already gone through that, why that printed that. But here, we're printing constant of X. And the constant of X happens to be equal to this data pointer. So there's a couple of concepts we need to go through. Let's go take a look at a report first. I'm going to go over and click on reports, and because we added this meta command, we want to create this report. This report right here, the string constants table report, is available. So I'm going to click on that, and it highlights it. So notice here it's showing you that in your program, when it compiled this, that this data is part of your compiled program. And in the first slot, it has the data of hello world. So the compiler, what the compiler has done is the compiler has actually stripped out that hello world and stuck that data into the string constants table. And that's what this is here, the string constants table. It's a table of string constants, happens to have a length. Now this is a hexadecimal value, B. B in hexadecimal is 11 in decimal. And this is 11 characters long. So there's your first string constant. It's in slot number 1. The second one is your JQ public. Your third one is it cannot display the copyright symbol because it's just printing out text that could be read by any program, standard text. So it just converted that into a dot. But there you see dot ABC. But it is 4 characters in length. And then the fourth one was the world is round. So I'm showing you the string constants table to point out. Now to get back, I'm going to click on source files and then go back and click on the source file we were using right here. That all of the string constants in your entire program, as the compiler compiles, it strips the string constants that you've declared in your source code, it strips them out and shoves them into a table. And then you can access that data by using this function constants. So for example, if we did this, and I will add a whole line of like that so you can see this, that after this double line prints is we're printing the value of whatever happens to be 4. Now we know, I showed you earlier, that 4 is going to be the world is round, but just go ahead and run this so you can see it. And there it is, the world is round. Now the data pointer, this as the compiler is compiling, okay, it is every time it compiles and adds another string constant to the table, the data pointer is pointing to the next string constant. All right. So if I were to come up and I were to put x equals the data pointer here, it is going to, when it compiles this line of code, when the compiler compiles this line of code, it's going to say the data pointer's value is 1 because it's going to point to the very first or the next slot. All right, it's always going to point to the next slot. So you have to put the data pointer ahead of the next one. But if we did this, and then this printing this constant, this will print the hello world. It'd be the same as printing hello world because constant string sub x is going to equal that. I'll just go ahead and compile and run it so you can see it. And there it is. All right. And if somebody's saying, well, why in the world would you need to do that? Well, there's different reasons why you might want to be able to put a bunch of data in and then be able to access that data numerically. All of this data is going to be into that table, and this just gives you a way of accessing that table. You may never want to use it, but I said I would explain each and every one of these commands. Generally speaking, you're probably mostly going to use this to access information in the application data tag. So what I'm going to do now is I'm going to show you how to actually use some of this information. Give you a real world example. So I'm going to hit F9, and it printed out that the current version that I'm using to create this program, compile and run it, is this version right here. Now, if you click on this button, this is the master runtime window. If you click on this button, it's going to tell you that here's the version, and notice right here, that number is the same number that's being printed out right here. Okay. If I hold the control button down and I've got it being held down right now, and click on the button, it tells you that the master runtime window text, the text grid was copied to the clipboard. Now, if you're not familiar with the clipboard, anytime you copy and paste something, it goes to the clipboard. So for example, if I set up a new text file, I open it up, and now it's being opened up in Notepad. So this is standard Windows Notepad. And I were to come over and then paste it, the data that's in this window right here got copied to the clipboard because I held the control button down and clicked on this button. And so the runtime engine copies it to the clipboard, and the runtime engine's doing it. Notice the red. The red means that my program has already terminated. But just because the program's terminated, the runtime engine is still active until we exit out, or in this case, if you're on the red border, you can hit escape to go past it, and then the runtime engine will close. Okay, so I've got that data on the clipboard, which means I can come in here and I can hit the same thing. I got it over here, I can hit paste just to get that data into here. So let's go to the bookmark and let's look at our string comparison functions. All right, I'm going to copy all of this for the moment down here into my scrap area past the end. Because anything you put past the end meta command, the compiler will not read that. You can put anything you want down here and come back and get it later. So let's talk about the equal. And what I'm going to do is I'm just going to say print equal, and then I'm going to go ahead and double click on that so you can look at it. And let's look at the syntax for this particular function. You have a string 1 and a string 2. So this is your first string expression, your second string expression. And it's telling you here the output will be 0. False means 0. Or 1, which also means true. So if it returns a 0, that means that string 1 equal to string 2 is false. All right, so let's, for example, ABC string to ABC string. All right, and then I'm going to print like this. So we're going to print two conditions. Now go ahead and take a look at this. So the A line, where it's doing the comparison, the result is 1, and 1 means it's true, and on B it's 0, which means it's false. So again, this string comparison function, it's comparing this string with this one, and it's going to return a value that's either 1 or 0. The 1 means true, 0 means false. So in this case, this string exactly equals this string, so the condition that it returns is true, or 1. Okay, next I'm going to talk about the not equal. All right, so if I were to put not equal, and I'm just going to do just one line, and that is going to return, if these are not equal, it would return a true value, right? And it returns false because they are equal. So that's what you're looking for. And the way you would use this is, you can put this in an if then else statement. So here, what this is saying, if this condition is true, if this evaluates to a 1, then whatever's in this between the then and the else will get executed. Otherwise, whatever's in the else will get executed. So it'll be the same as saying if true, then, and I'll go ahead and run this. If true, the strings are not equal. If false, See, it says the strings are equal, right? So if this function returns a value of false, it's going to then print the strings are equal. So obviously if the not equal is not true, it's the reverse or the inverse of it, right? So let's go ahead and put this in right here. Go ahead and run it. So it's telling you that the strings are equal, all right? What might make it simpler is if I change this around and just went with if equal, these two things are equal, I got to change this. So if it's equal, then if it's true, it's going to print that, right? See, if I took the not out, I had to switch these two, right? So there we go. Now, this is where you start using variables, right? So let's say if we have a string equals, and we say b string, and then we want to compare a string to b string. Is a string going to equal b string? Well, I can tell you right now that it's not just by looking at it, because when you're comparing these, and if it's equal, it has to be, remember, let's go back and look at our Ascii chart. Okay, every character would have to be the same, and the lengths would have to be the same. So in this case, the strings are not going to be equal. I'm going to go ahead and just compile and run this. All right, and it says the strings are not equal. And they're not equal because the uppercase A has a value, a hexadecimal value of 41 hex. But the lowercase a has a hexadecimal value of 61 hex. So they're not equal. All right. Now, you can do something else. There is a command, and I'm going to jump ahead just to show you. Uppercase string. And what uppercase string does is it automatically converts the case. So it takes any it scans the entire string, takes any lowercase letter, converts it to uppercase, and then returns a string value. And I'll just skip over to that, and you have uppercase string right here. So there's your input string, and then it outputs the result string. And so the result string would be being fed into the second parameter. So if you can follow this, the uppercase string of B, which would in fact be a string that would be identical to what A is, okay? Because it would uppercase each one of those letters. And then that would be returned as the parameter 2, the second parameter. And so that string would sit here. It would then be compared to a string, and then the comparison is going to return this here, this function, this whole function here is going to return a true or a false value, which is going to control the logic of this if then else statement and print whether or not these strings are equal or not equal. So I'll go ahead and run this and you can see. So they are equal, all right? Because what we compared was equal. A and B are definitely not equal, but we're not comparing A and B. We're comparing A to the uppercase of B. So I went ahead and set up another example so we can look at the less than string comparison function. So we have that right here. And let's go ahead and take a look at what this is doing. We're comparing A string and B string to determine whether or not A is less than B. So this function, less than function, if A string is in fact less than B string, it will return a true result. And so therefore this if then else and if, this structure here, this logic structure, if this evaluates to true, it will print that it'll print the value of A string, and it'll put it in single quotation marks. Right there's a single quotation mark and another single quotation mark. So it'll put the value of A string, and it will state is less than and the value of B string. Okay, so let's just go ahead and run this and see what it does. So there you can see where it's saying that the value of A1, okay, this is a string value, is less than the value of A2. And when it's doing the comparison, the first thing it's comparing is the first character of each string. And it's trying to determine if the first string is less than the second string. So in this case, it compares the first character of each string and they happen to be equal. So it can't make the determination based off of the first character. So it moves on to the second character. And it says, is the character of 1 less than the character of 2? Now it's not comparing the value of 1, it's actually comparing the ASCII value of the character. So let's go take a look at that in the Ascii chart. And the ASCII code for 1 happens to be 31 hex. And the ASCII code for 2 happens to be 32 hex. So therefore, you can see where, yes, 31 is in fact less than 32. So it evaluates true and it shows you this. Now, we could have the plus sign as the character. So instead of saying 2, let's say A plus. Now, if you look at this, the plus sign has, the ASCII code for the plus sign is 2B. And 2B is actually less than 3.1. So I can tell you now, right now, just by looking at it, that A string is in fact greater than B string. But let's go ahead and just run the program and see what the string comparison function says. And yes, it comes back and says that A1 is greater than or equal to A plus. So it's comparing, it said the first character compared, it was equal. The second character, the ASCII value of this character was greater than the ASCII value of this character, and therefore when it's compared to two strings, this string is actually greater than this string. Now I'm going to go get some other data from down here. I'm going to change these so that we can look at this. And so I'm going to change the A string equal to the word of abandoned and the B string equal to the word of abandoned. And the only difference between these two is it has an ED on it. So I'm going to go ahead and run this and see what it says. And it's telling you that this is less than this. And the reason that the first string is less than the second string, all the characters here are the same. Let's go take a look at this. Drop the space out of here and make it easier to see on the screen. So if you notice, all the characters up to this point are identical. Then this string here doesn't have any more characters, yet the B string has the E and the D added on. The value of E is greater than the value of a nothing. So therefore, the A string is in fact less than B string. Okay, so here we're taking a look at a real-world example of using this less than function. So we're going to compare the string value of the current version with the string value of the minimum required version. So what I've done is I've just declared the minimum required version to be equal to this string of data right here. And to get the current version, we're using this function, the const function with this keyword constant. Now, I'm just going to show you this real quick, that in the documentation, you will notice that this here, executed min version, that is this right here, and this is telling you that this is extracted at runtime, that this data is extracted at runtime from the Sybos runtime engine executing the application. So that way we know that this string value is going to be set equal to, and let's go ahead and run this with a pause, and I'll show you where it's pulling the data from. So anytime you click on the master runtime window on this button here, it will bring up this About Sybos Runtime Engine. And this right here, this Sybos 3.0, this is what is going to be equal to the major version number. And then the minor version number is going to be equal to this data. Now, this was structured specifically so that the minor version number included the actual major. It just doesn't have a dot there. So if this was Sybos 4.0 this would be 0400, all right? So the first 4 digits here represents the whatever's here for the major version. So the major version, it could be like 3.01, and if it was, the first 4 digits would be 0301. All right, so there's your major version number built into this string. Now, it has a dash, and then what's here is a build number. So the build number is your true version of the Sybos runtime engine, because every time something gets added to it, then the build number goes up. Okay, some new commands, some new functions get added to the language, maybe a few bugs get taken out, whatever, you're going to have an increased build number. If there's major changes, or a whole lot of stuff gets added, or a paradigm change happens, that's where you wind up with the major version number increasing, okay, to 3.1 or something like that. But if there's just simple, small little minor changes, or a few newer commands have been added to it, it still might be version 3.0, and it just simply has a higher build number. And if that's going to be the case, there will be some documentation somewhere on that fact. But here's the thing. Generally speaking, what you want to do, if you're going to create an application that you're going to rely on, or that maybe you're going to give to customers or other people and they're going to rely on it, one of the first things you want to do is you want to test the runtime engine being used to execute your program. Now, you can always create a standalone application and the runtime engine becomes a part of your application and it's fixed, and that's the safest thing to do. Okay, but you should still test it, and you could test it if you only want a certain version to be used and no other version to be used, to guarantee that, hey, I tested this thing completely. You could have, instead of a minimum required version, you could actually say the required version is, let's create a separate block of code. I'll drop this out for a minute and throw this down here. Throw this into our scrap area and come back up. And so this block of code here is testing for this required version. And this required version happens to be exactly the version that's installed on this computer right now and is being run. So it's going to test, and because it is equal, it's going to jump over this entire block and it's going to go on and execute the program. So I'm going to go ahead and run it so you guys can see that. So there you go. All right, it tested it and it passed the test. So the program ran, and in this case it printed this line and then exited. So there's an example of a block of code that requires a specific version. Now I'm going to go ahead and get rid of this, and I'm going to bring back this text right here. Okay, now what we're going to do is just going to talk a little bit about how this works right here. And if you notice, I added this name meta command so I can name the program, and I just named it my program, the text my program. And the reason I did that is because this const name, this will return whatever text is in this right here for the name meta command. So the message box, the first parameter, it's putting that in the caption. Okay, so let's actually go back and let's look at this under the message box and bring this up, and you'll see string 1 is the message box caption. So there's the caption, and then string 2 is the message box message. So what I've done is notice anytime you have text in quotes, it is a string constant. So we're having the string constant of all of this right here, and you can see that that's printed right here. And then I put plus, and came down to the next line, and I put supported. And then I put plus, and you see where the OD, and then you have OA and OA. OD is actually a carriage return. That is like a control code. It's a standard ASCII. I don't think I have it listed anywhere that I can find easily in the documentation. But this is standard ASCII, that OD is a carriage return, and it causes, in the message box, just comes over here a carriage return, and then OA is a line feed. So OD, OA, carriage return, line feed, and I have a second OA because I wanted to have a second line feed. And then it says please use version number, and of course it's not spelled right. It's got the T in there. I'm not going to rerun it, but please use version number. It prints then the minimum required version number, which is the text from right here, and then comes down plus and then or higher, and then there's a comma. So remember, this is a string expression. String 2 means you're going to have a string expression. And so you can add all of these strings together as this is a string expression, that all of this data is then passed to string 2, your parameter, and that becomes the message. So I really wanted to point out a real-world example of using string concatenation or string expression as a parameter. And then, of course, the third parameter, the int3, is one or more of the MB message flags. So let's go ahead and hit this bookmark again and come over. We've talked about already the length and the len max. Just to touch on it one more time, if we have a string equals, and I'm just going to put 1, 2, 3, 4, 5, so it's clearly there's 5 characters there. Print the length of a string, and again I'm going to then underneath of that I'm going to print len max subdummy. So the length of a string is 5 characters. The maximum string length is 500,000 characters. Again, that's with current settings. Okay, let's go to the bookmark and let's move down. ASCII text string, to and from numeric data. Oh, this is good. We have the A string equaling 1, 2, 3, 4, 5. So let's say we want to put that into an integer value. Lowercase x integer equals of a string. And you'll notice here you have a string expression. So effectively it's going to turn that into a number and put that here. And then what I'm going to do is I'm going to say print x integer, and I'm going to say print x integer plus 1. So there's your integer value and your integer value plus 1. You could even do this. You could say times 3. Okay? Because this function is returning a numeric value that you can do something with it. So I'm going to go ahead and run this so that you can see it. And it works just fine. Okay, now let's look at the integer string. And notice that in parentheses it's an integer. So in this case, what I'm going to do is I'm going to say, let's say a string equals the lotto number is plus a string, right? And then you could just simply print b string. All right, and so b string is this entire text from here to here. Okay, let's move on down. Let's talk about the float and the float string. So I'm going to skip over to page 31.5 because it has some good information on this. Let's just start off with a equals the float of, and we have a number in a string here. So this is a string value that's got 777.55. So let's go ahead and run this. So there you go, a equals 777.55. And if we go back and take a look, let's say we want to use an exponent. So I'm going to use what they have here in the example is a minus 1.45 e to the plus 22. And then I'm going to print a. So let's go ahead and take a look at that. So there's what you're getting. So this is floating point math. Negative 1.45 with an exponent of positive 22. Okay, so let's go ahead and take a look now at the float string. So here we're going to take a floating point value, and go ahead and look at this here, where so you have a floating point expression here. We could actually have divided by 2, okay? And then we could take the value of this expression, convert it into a string, assign it to a string. So there you go. Let's move on. The value VAL is the same as the float function. So let's come down here to number string. Number control data. This is basically a formatted text string. So we have a string equals number string. So we can bring this up and look at it. The value to be converted to an ASCII string. So as an integer. So let's say as an integer we want 1, 2, 3, 4, 5. As an integer number, it's going to be converted to a string. Well, let's just run this as it is and see what it does. So what it's done is it's added a space. It's also added a comma and another space. So you got a space on each side and then a comma. So this is formatted data. And I did that because what you're looking at is kind of like a default formatting. And so you have two things that are going to control this here. Number controlled data. So let's put this on here. And let's just go take a look at this. And what this is telling you is it's going to format everything here, the number. The int1 is the ASCII value of the monetary character. The default is 36. Int2 is the number of decimal places. So 0s through 6 are valid. So here we have 36, meaning the $ character. 2 would be have 2 decimal places, and the fixed field size would be 8. So I'm going to go ahead and just put this in and run it and see if anything happens that's different. All right, and what's different is, notice that you have 2 decimal places. So it took the 1, 2, 3, 4, 5. That's the integer value, 1, 2, 3, 4, 5. But when it went to format it, it formatted it with 2 decimal places. So where this would come in handy, I'm going to get rid of this hello world. So we got account balance as an integer variable equals 1, 2, 3, 4, 5. And maybe we're going to keep these balances in pennies, right? So that would be, $123.45. So when we go to print that out, we want to convert that into a monetary number. We want to have 2 decimal places. So in the number control data, 2 decimal places. There's a reason why we want 8, maybe we want 8 characters, maybe we want 10 characters, right? And the reason is if you're printing a bunch of data, okay, let's say you have account balance of 1 and then account balance of 2, account balance of 3. Okay, so what we have here is we're just going to use an array, which means the first element of the array, the account balance, the first element will be equal to 123. The second element is equal to 1, 2, 3, 4. The third element 1, 2, 3, 4, 5. Right? Then the first time we're going to convert this balance into a string, and then we're going to print it. And then on the next line, we're going to convert the second element into a string, print it, and so forth on the third. So let's go ahead and just run this to see what it does. It is giving us 2 decimal places. So the first time through, it's showing you, if we were to read this in money, $1.23, $12.34, $123.45. And let's take a look at the actual number control itself. So there are there's 2 things that are going to control how this data is formatted. enable fixed field. See this flag right here? Here is enable fixed field, which means we want to print 10 characters for each one of these, and enable the money character. In this case is the dollar sign. Go ahead and run it, adding this command in right here. Let's go ahead and run this thing again. And there you go. Notice what's happened. So now we have 10 characters being printed, whether or not they're all used or not. And you have some different options under this number control. You can have parentheses. Sometimes if you're doing accounting type work, you might want to have negative numbers to use parentheses. So I'm adding different flags in. We enable the money character, and we make it fixed, and we have the fixed field. And then there you go, that's what we get. Okay, if you want more room for bigger numbers, okay, and if you don't want these leading spaces, the trailing spaces, well, you come and get the flags, omit the leading, and we're going to omit the trailing. Okay, throwing all these different flags in, controlling how this number function is formatting the data you give it. So there you go. Okay, the next thing I'm just going to go ahead and erase all this on the number string. And the next thing I'm going to do is show you guys how to use the num and the num-lz. So let's just say a string equals the num string sub, and let's see how this works. The first parameter is the integer data to be formatted, 345. And then the field size being the number of characters. Let's say the character is going to be 5 characters. So you can see that there are 5 characters here, and I click on this. This makes it even easier to see. So you can see here that between these two arrows, you've got 5 characters, and you've got the 345 and a blank blank. So what's happened is it's taken this number here, right? And it set this number into a 5-character string. What's interesting is, let's see what happens if the string isn't big enough to hold it. So here we have a 6-digit number, and we're only going to give it 5 characters to put it in. And you're going to see what's going to happen. It generates 5 pound signs. And that's kind of like a visual indicator to you that there's an overflow, that that number won't fit in the field size. Okay, so that's num string. And what I'm going to do is I'm just going to print 12 into 5 characters. That can come in real handy doing a for next loop. For I equals 1 to 20. Okay. And maybe you'll say print. If you say print I, and you go to something, say if you do something like this, and maybe there's some data that you're going to print, and then you do next. So this is going to give you a loop. So what this is going to do is just going to print the value of I and then data. So let's watch what happens. Notice that it printed the ones, and then 10 is obviously 2 digits long, and it kicks all of your stuff over further, right? Let's say you want everything to line up nice and neat. Well, then you could use, instead of just I, you could stick in num string, and for the value going in, right, you could have I, and then you could have, let's say, we'll just say 3 characters long. Take this out. And then watch what happens here. Okay, first off, you'll notice that everything's lined up as far as you got 1 to 9 and then 10, and notice how it kicks it out this way because there's 3 characters here, right? You can see it, clearly see it. Now let's say you wanted to have a leading 0. Well, that's where this other command LZ, which is right here, let's go ahead and rerun this and you'll see it. So there you go. So that takes us to the end of that. We're now going to talk about the pure string functions. Okay, so we're going to talk about mid string, left string, and right string. So let's say we have some text. Say we have a string equals, and say the world is round. Okay, so let's say that's our string of data. We can print that, print a string, and that's what you're going to get. You're going to get the string. Now, let's say we want to use, maybe we want to, for some reason, want to get just the first 5 characters of this string and assign that to a different string. So we could say B string equals the left string sub A string. Let me bring this up on the screen so you can see the syntax. The left string equals, so here's the source string expression. So let's say we want to have A string as the source, and then the requested number of characters returned. We want to return 5 characters. Now I'm going to bring this back up here, and I'm going to change this to B string. So I'm now going to show you, I'm going to rerun this. Let's run it and see it again. So here you have A string is the entire thing. B string is just the first 5 characters on the left side of the expression. And because we only used A string for the expression, it took, right here, under this parameter, it took the first 5 characters of this. And I call this an expression. And the reason I call it an expression is because you can do something like this. Put a couple stars there. Say put 1 star plus. So that's string concatenation. If you were to do that, it's going to take and add this string and this string, and then it's going to create a resulting string that's combined, a combination of all of that, and then it's going to take the left string, in this case 5 characters of all of that. And to show you that, let's just go ahead and run it again. So there you go. And you get the star, the, and then of course the space came from right there, that space right there. Okay, so that's why I call it a string expression. The right string simply means that we're going to pull it off the right side. So here, it's going to go from here, five characters starting at the very right side of the string expression. So let's say we go back to our star plus A string. Okay, our string expression would basically, that would be the same as putting the star right there, right? Let's go ahead and run this again. Now you notice A string does not have that star on it, because we didn't add the star into A string. We added the star to the expression. We added the star to this expression that we then took the right string of. We never put that star into A string, and we're only printing A string. So I kind of wanted to point that out. That's why the star is not there. But we'll take 5 characters from the right side. So let's go pay attention. Let's rerun it again and pay attention to that. And so there's your 5 characters. There's 4, and then the period is 5. 5 characters off the right side of the expressions being fed in. So again, if you put, let's say we put a $, right, in quotes. So you're talking about the text, right? So we get star plus A string plus the $, in quotes. Now I'm going to go ahead and run it again. And notice that that $, because it was part of that expression, you have 5 characters. So you get the $ and then the last 4 characters of this, because it got added together. Okay? Now, let's say you want to take, we're going to talk about, I believe we're to the mid string. Yeah, let's talk about the mid string. Mid is middle. So, the mid string of, and I'm just going to go back to A string. I think I'm going to make my point with the expressions. So let's go ahead and run this, and it's going to take the mid string of A string sub 5. And notice it's not blue, it's black. The fact that that's black is telling me, oh, I did something wrong. I didn't add the $. So the $ is part of the keyword, mid string. $, say it as string, mid string. The moment I added the $, the whole keyword, including the $, turned blue. So now we know we actually have a valid keyword. And I'll go ahead and run this, and then we're going to talk about it. So it picked up the 5th character and then everything else. I'm going to add something to make it a little easier for us to view this on the screen. Watch what happens when I do this. So it makes it a lot easier to see the fact that the W is the 5th character of A string. So what's happening is mid string has returned from the position number 5 onwards. It returned from the middle of the string on. And let's look at the syntax. So here's the syntax for mid string. The source string expression and the starting position in the source string. Now, it says if int3 is omitted, and we didn't have int3 here, and we omitted that, then it's all the bytes, all the remaining bytes, so it will end up being everything. However, let's say we only wanted 3 characters. We want to start at position 5 and return 3 characters, the number of bytes to return. Let's go ahead and run this. And there you go. Okay, starting at position 5, we're returning 3 characters. Now let's move on to trim, left trim and right trim. So what I'm going to do is I'm going to add some spaces. I'm going to leave this here like that. I'm going to add some more here. Now what I'm going to do is I'm going to say B string equals left trim. String. Sub A string. And let's look at the syntax. So you have one string expression. And let's go to the manual to see what it says. The purpose of these is used to return a copy of a string expression with the spaces and or leading zeros removed, okay, as follows. So the L trim, left trim, strips spaces from the left side of a string expression. So here's, see all these spaces here? It's going to strip them. So let's go ahead and run this. So there you go. The original string had all these leading spaces. That L trim got rid of the leading spaces. R trim, well, in fact, I'm going to leave L trim on there, but I'm going to add some leading space. I'm going to add some trailing spaces. And then I'm going to run it again. So you can see clearly that A string has both leading spaces and trailing spaces. B string, the spaces have been stripped on the left side, but not on the right side. So we could use R trim for trim the right side. Okay, now you have them on the left, but not on the right. Or, let's go back and let's look at all of them. You can have trim, and trim strip spaces from both sides. So if we go ahead and do this now, there you go. Just using the trim, it trimmed the spaces from both sides. Now notice this L trim 0 string. If for some reason, maybe you had a number that had a bunch of zeros in it, 2, 3, 4, 5, the world is round, all right? So let's go ahead and just show this here, and you see what you have. But if we go in and we use this ltrim0 string, okay, so notice what it did. It stripped both spaces and zeros. We've covered all of this. The upper and lowercase, let's use the uppercase string of a string. Let's go ahead and look at this. So notice what it did is it took all the data in A, it uppercased every lowercase letter. Okay, so there you go. The uppercase string function simply uppercases all your lowercase letters. On the other hand, the lowercase will simply convert everything into lowercase. So there you go. Even your uppercase letters go lowercase, lowercase stays lowercase. All right, let's move on. Okay, an ASCII byte to and from a numeric. So let's say you say the A string equals the character string of 65. We don't need B string now, so just take that out. All right, so the A string of 65 equals the uppercase A. And that's because this is a decimal value. If I go back over here to the ASCII chart, this chart is in hexadecimal. Now, I think we've talked about this, but if you use 4 digits between curly brackets, you are specifying a numeric hexadecimal value. 2 digits between curly brackets, and it is a string value. And what makes it really easy to tell what you have is the string value. The Sybos application developer is detecting that this is a string value, and that's why it made it red. This 0, 0, this 2 leading 0, 0 is simply because you have to have that in there because there, that's string data. But if I put the 2 leading zeros there, it's 4 digits long. It now converts this into numeric data. So here's the character string of the numeric value of hexadecimal 41. So now we can go to our chart and we can look at that, and that is the uppercase A. For example, if we wanted that copyright, it's the A9. So I'm just going to go ahead and put in A9 and show you what's happening. That the character string is going to convert the number into a string. So let's just go ahead and print this. So there's the copyright symbol. So the A string is equal to just one character of data that happens to be that copyright symbol because it is the value of A9. You would never actually use this in your code because it's just a whole lot easier to use this, right? Because it's going to do the exact same thing. Right? Just like that. That's the easy way to do it, to get that result. But what we're doing is we're showing you the character string function. And the reason is that you can put a variable in here. I'll give you a great example. So this is a loop. We're going to go from 31 to 45. We're going to print out the value of I. We're going to point an arrow to the character string of I. All right, the value of I. And so there you go. So 31 is equal to, we got the V. I suppose I shouldn't have started there. 32 is a space character, and then you've got all these different characters here, right? I could have started at 65. That makes it 64 to 78. All right, so 64 is your ampersand. There's 65 is your A, all the way down to 78, which is your uppercase N. Okay, so there's a great example of how you might use character string. with a variable. You need to convert a variable in. The opposite of that is the ASCII string. So if we go back over here, ASCII equals the ASCII value of, let's say, A. Okay? And print X equals X. So you can see what's happened is the ASCII value of A is 65, so the value of 65 got assigned to X, and then we printed it out. All right, let's move on. Okay, now we're going to talk about a conversion, a byte. So it's telling you the string expression and the starting position in the string. So we're going to have a loop. It's going to go through the loop. In this case, the length of a string is 5 characters. So the loop is going to go 1 to 5. And so I will equal 1 the first time through the loop, I will equal 2 the second time through, all the way through to 5, and then the loop will exit. And while we're in the loop, we are going to print, and it's going to return a numeric value. Okay? So we are going to print convert byte, and we're already converting. Well, here's the string expression is going to be a string. And we want to convert the byte of the position in this string. We want the starting position to be I. So each time through the loop, I'm going to go ahead and run this so you can see what it does. So here you go. Each time through the loop, it's printing. So we know that's hello, okay? And if you weren't sure, we can say X equals this value right here. And then we could say print the character string sub X, a couple spaces, and X. All right, and we'll go ahead and run it again. So what you see is here's your hello. So, and here you're showing the value. So the value of H is 72, the value of E is 101. Now again, these are decimal numbers. If you want to see this in hexadecimal, if you want to print out the X in hexadecimal, you can do that by using the hex string, which we haven't covered yet, but I'm going to put this in here. Okay, and I'll go ahead and run this. And there you go. Your capital H is 48, your E is 65. And if you're going to go look at the chart, again, H is 48. If we go look at the chart, you will see on the chart that that's in fact what you have. So capital H right here is on 4 and then the 8. All right. So that's what the convert byte does. All right. It's the same thing as the ASCII on a byte. All right. ASCII of this, except remember the ASCII only had one parameter. Right, so if we go back and look at ASCII, you only had one parameter, and it took it basically takes the first character of this string expression and returns the value, where the convert byte gives 2 parameters, so that you have the second parameter here, the starting position, so that you can adjust the position. Otherwise, you would have to use like midstring to pull out what character you wanted if you were to use ASCII and try and get the same result here. So instead of converting byte, let's go to convert word. A, B, C, D, and then I'm going to step 2. The reason I'm going to step 2 is because a word is 2 bytes. So the first time through the loop, it's taking the A and the B, and it's converting that into a word. A word happens to be 2 bytes, and it reverses them. It sticks them in reverse order, okay? Because it's like a word is a numeric value. So the A is 41 hex, the B is 42 hex. So this is actually taking the string data right here, and it's converting it into a numeric value, which is equal to a word composed of these two pieces of string data. Let's go back to this, and if you want to do the entire integer, okay, convert integer. These are 32-bit integers, so this would be full 32 bits, which in this case we'd have to step 4. So every 4 characters. So it's going to take the full ABCD and convert that into an integer value, and then it's going to print the hex of that value. And let's just go ahead and look at this. And you'll notice here where it's 41, 42, 43, 44. It's kind of, they're all in reverse order. But this is the way in memory that the string data right here is stored. So a value, an integer value of this value right here, hexadecimal value, actually gets stored the same way in memory as the string data ABCD capitals. All right, let's move on. All I'm going to say is that the rest of these is the reverse, okay? Where this is converting a string into a number. If you need to convert that number back into a string, then you would use like convert integer string, okay? And that would just do the opposite. And I'm not going to get into converting float. Okay, special purpose string functions. These are very important. So let's go ahead and talk about binary. We've used this once or twice before, but let's say we say print the binary string of 5. And so 5, the value, the numeric value of 5, the integer numeric value of 5 equals all these zeros and then a 1, 0, 1 at the end. All right, that is binary 5. Okay, let's move on. The next is the hex string and the pure hex string. So we've used the hex string example. I'm going to go ahead and just print hex string of x integer. And then I'm going to print pure hex string of x integer, just so you can see the difference. So this makes it easier to read, and this also happens to be the same way that the language can read it. And the reason why I put a space in here is because it's a whole lot easier for you to visually look at your code and see this compared to all of this. All right, let's move on. SP. This is good. This is just going to just generate a bunch of spaces. And I'm just printing the X and the Y just to have something on the screen so you can see that we printed 3 spaces. Go ahead and put the grid up so you can clearly see the 1, 2, 3 spaces between these two. So this command, if we go look at it, and all it does, it's the repeat count, the number of spaces. Let's look at it in the manual. Under the purpose, the function returns a specified number of spaces. ASCII code 32 is a space. You also have the string function. So call this string. And int2 would be the code that is repeated. Right? So let's say we wanted to have a 65 being repeated. Right? Or let's do this in hexadecimal. Your 41. Right? Which is the A. So I'll put some spaces in here, make it easier to read. They don't have to be there for the compiler to read it. So we're going to print an X, then we're going to print a string that's 3, the count is going to be 3 of this character, of this ASCII code, followed by the Y. Let's go ahead and print that. So you've got the X, the 3 A's, and the Y, right? And remember, if We change that to like A9. That'd be the copyright symbol. So we'd have the X, 3 copyright symbols, and a Y. You see the string underscore FB? Well, that's because first byte string. And that would be, notice this is integer 2. Integer 2 is here. Here, this command is specifying that the second parameter is string 2, a string expression whose first byte is used. So we could have a string expression of, say that right there, and only the first character, in this case the B, will be used. All right, so there you go. You have 3 B's in a row. Let's move on. So I covered those. The swap statement. I'm going to go ahead and print these. Okay, so let's just go ahead and just run it to see what we have. And you can clearly see A is the first, B is the second. Now there's a swap command. And click on this to see the swap a variable 1 with variable 2. Okay, now they just have to be of like type. Now remember we talk about data types. I'm going to go back to page 33, I believe it is, in the manual. 33.3, yes, data types. So here's your data types. So if you're going to use the swap command, you got to swap, you can swap 2 integers, or 2 floats, or 2 strings. So as long as there's the same type, it'll work. Swap A string with B string. And notice A string is now the second, and B string is the first. So swapping them just literally took whatever data's here and stuck it in A, and took the data in A and stuck it in B. I won't even get into the number of places that you can use something like that. Okay, it can become very handy in certain situations when you're programming. I am going to talk about arrays for just a moment. Let's say you have you want to swap 2 arrays. You want to swap out the first element of A with the 6th element of B. So again, if we're going to swap it so that the second goes into A sub 1. Okay? And it might even be more visually appealing as if we do this. Let me say A string sub 2 equals A string sub 2. Okay? Of course, then we have to swap A string. So you get the first element of A, the second element of A. So there you go. Okay? See how the first element became the data that was assigned originally to the second element and vice versa. Okay, let's move on. So we're down in here into the string search functions. We're going to talk about the INSTR. Let's go ahead and run this. I set something up here. Let's take a look at it. So here we got A string, and notice that the world fair is great is our data. What I'd like to do is I'd like to extract the word fair out of this statement and create B string that it says the same thing as A string but without the word fair. And I want to do that automatically. So even if the length of A string or if there's other data in it, we're just going to take out that one word. So the way that that can be done is with the INSTR. INSTR is INSTR. So this function, notice here the first parameter, string 1, is our target string. So our target string is going to be A string. That's what we want to search. We want to search this starting at position number 1. So The second parameter here is a starting position to search in the target string. So here 1 is where it's going to start searching in the target. The substring, that's the string we want to find. Okay, so I'm actually going to call it substring. Now this is returning a value, so I have to do something with it right here, and I'm going to assign it to something. So what I'm going to assign it to is SP for the start position, because it's going to return the starting position of the substring if it finds it. If it doesn't find it, it's going to return a 0. Notice under the out, it'll return a 0 if the substring is not found, or it'll be greater than 0 if it is found, and it'll be the position in the target string that the substring was found. So I am then going to have a substring, put that here, and then we're not going to use wildcards, so I'm just going to put null for none. I'm not going to discuss those, it's a little advanced. Okay, let's run it and let's print SP. And so it's showing SP is at position number 11. So fair is right here. So there's 1, and I put a dash in for a 0 just to make it easy to count, like here's 10, here's 20. Okay, so it's obviously you're at position number 11, the F for fair. So even if we were to add some extra spaces here and I rerun it, the INSTR command is going to return the starting position of the word fair right there, 14. Okay, so that's what the INSTR function is doing for us. Now I'm going to show you how to use it to do what we said. We said we want to extract out and we want to create bstring. And what I'm going to do is go ahead and print it down here. We don't need the SP up there. Print the SP down here. Okay, so we now need to create bstring. So I'm going to say bstring equals. The first thing I want to do is I want to start with all the characters up to that SP, up to the F, right? So I want to say bstring equals, let's use left string. So take the entire left of A. Now, if I take it all the way to the SP position, it will include the F. Matter of fact, let's just do that so you can see it. All right, so for right now, I'm just going to start off with the B string equals the left string all the way to that position. Let's run it so you can see. So there it is. B string is pulling all the way to right there. Again, if we were to add a bunch of anything, okay, hit F9, okay, it's going to, B string is going to grab all the way to the F, okay, because that INSTR function is finding the fair, in this case, at position 22. Now, if we do not want to include the F, we need to -1. It's SP -1. So here I want to say SP -1. I'm going to take these out. I think I made a point on that. And I'm going to go ahead and rerun it. So now B string has the world space, but we do not include that F because we did the -1 out. Now we want to add, and what we want to do is we want to add the mid string. We want to add from after the word fair everything else. So we want to add the mid string sub the A string. I'll go back and show mid string on here. We only need the second parameter. So we need to say, where do we want to do it? So it's going to be at the SP position, right, plus the length of the substring. So it's going to take the SP position, which is going to be on the F, then it's going to advance the length, which would be 4 characters, which would take it to right here, and it's going to add that on. So now we're going to have, and let's just go ahead and run it and see it. Okay, now we're almost done. Notice we've only taken out the fair. We got a space on both sides. So if we look at this, you'll notice, bring the grid up, there's definitely 2 spaces there, right? So the easiest way to get rid of the second space is to include it in the substring that we want to remove. So now we're saying the substring we want to remove is the fair plus one space. Now I can rerun it, and there you go. Let's move on. The in-string count. I'm going to print the count down here. Just to make it easier to read, I'm going to line all these up. And I put some lines around it. This is just personal preference. These lines here wind up being remarks. What this is doing is this is returning, here is your in-string count function. Notice the in-string function, the out, the in-string count function. The out is the number of times the substring was found. You hit F9 to compile and run it. The count was 1. Let's say it was in there again. All right, now that's going to be actually in there 3 times, right? And it counted 2. Actually, it was only in there 2 times because let's take a look at why. So we're defining our substring to be fair space. And we got fair space, fair exclamation point. So in fact, fair space is only in this twice. Let's move on. Okay, I'm going to go ahead and get rid of all this. Let's shove it down here in case we want to use it later. I love use scrap area. Just throw whatever you want down in the scrap area. You might come back to it later. Okay, I'm going to type in, I'm going to show you something else. Say if I don't want to type English word string, right? I go to page, section 43, page 68. So click down here, 43, come down to 68. Now, see these boxes here, they're on the screen in the manual. When the manual's up, you can't really click on it. You can't click on this because this is just an image of the manual. But if you go into quick ref, whatever's here, notice you got 2 things, the English word string and a find English word string. Go into quick ref and it brings up buttons with those 2 things on it. And if you click on the button, it looks it up, copies it to the clipboard, so you can come into your code and you can paste it. So I'll go through that one more time. If you're looking at something in the manual, for example, here, okay, what's in this box? Use as base 0 buffer or use as base 1 buffer. But point is, here's your keywords. So if you come up and click on quick reference, there you got your keywords. So you can click on it. It brings it up here. You can go back to it in the manual. But the most important thing is it's on your clipboard, so you can hit like the paste and paste it into your text. And you don't have to type it. Just click and paste. All right, let's go back to English word. We have one integer and it's returning a string. So let's print English word, and it says the number of the word to retrieve, or 0 to return the count and version tag information. So let's just do 0. Let's run this and see it. So there it's telling you that there are 19,829 English words in this word list version 1.1. What I'm going to do is I'm just going to assign that to X. I want to have a number. Matter of fact, I want to say count equals. Now, here's where you want to use something. If we run this, it's going to give an error. It's telling you type mismatch. The type is because if you look here, I'm going to click on this. This is returning a string, right? The string has the count in it, but it's string data. So what we're going to do is we're going to say the value of VAL. What is the value of that? I'm going to double click on this, right? So you can feed in, remember the float and the val, the command number 312, it's identical. So you can either say float return the floating point value of this number, or you can just use say val, V-A-L. So I want the value of this, and there's a reason why it listed the number first, so that specifically so you could do it this way. And then I'm going to say print count, all right, and run it. So there's your 19,829 in a numeric variable. And then what that allows you to do is say for I equals 1 to count. And then you can say print. Let's go back and look at this English word again. And the number of the word to retrieve. If I just put next on here, it's going to go through all 19,000 of them. All right. Now let's just do that. And you can see it spin on the screen. Okay. So there you go. It's printing all of them. Let's put the value semicolon. I'll show you an interesting way to do something. Okay. So just using that, so you can see it's printing the number in brackets, and then it's printing the word that is associated with that number from A to Z. Now, that printed that into all of this. Now, this screen here only holds about 200. Remember what I said about if you hit the control, hold the control down, click on this, it copied everything in the master runtime window to the clipboard, and then you can go into a text document. I'll erase that, hit Control V, and everything that was on the clipboard is now been copied. But there's only 200 lines because this master runtime window only has 200 lines. So let's say I wanted to copy all of this instead of to the screen. I wanted to put it into a text file. Okay, since this is the last example, we're going to go ahead and show you guys some stuff. I'm going to open up a file. Say fh equals open text file. I'm going to show you how to do this. I'm going to open a text file. Just I can have a path. See the string 1 master path, string 2 the path file name. I'm just going to put list of words. List of English words as opposed to other types of words. Dot text. I put dot text so that like Notepad can read it. Comma, and if any flags. I'll say allow erase. So if the file already exists, you can recreate it, and it won't throw an error. All right. Now notice I typed that in. Instead of typing that in, I could have came over here, looked over right here where it says allow erase. Hit copy, come into my code, and hit paste. All right. Now, instead of printing to the screen, I'm going to say print to file, FH. All right. And I'm just going to go ahead and run this. Once we're done, I'll close the file. Close file, FH. I do need to have a path. Let me stick it on the desktop. So the path I want to use is desktop string sub 0. And this, just to show you this, desktop string will always return a path equal to the current user's desktop, which means in this case, this is my desktop, and it will generate the file and probably stick it right about here. And so here's list of English words. And I just opened this up by clicking it. This is set up to open it up in Notepad. So here in Notepad, you'll notice there's the first word, abac, and then abacus, abandon is the third, and it goes all the way down. So you have built into this language 19,829 English words that you can use to create all kinds of stuff or do spell checking. So that ends this video. If you like this video, please give it the thumbs up on YouTube and go ahead and hit that subscribe button. And if you want notifications when we put out new videos, also hit the bell button.